All right, here we go again. This time we are just gonna do some practice problems using those exponent rules. Exponent rules, part 2. All right, so let's say I have 10 to the 4th times 10 to the 10th times 10 to the 6th. Okay, well, I could write out all of these tens, or I could picture in my mind, okay, if I write this out, I'm going to have 4 tens, 10 more tens, 6 more tens, so that's 10 to the 4 plus 10 plus 6, which is 10 to the 20th power. Okay, piece of cake. Let's do this one. If I have c to the 8th times c to the 7th, that's, writing it out, it would be 8 c's and 7 more c's, so that's c to the 8 plus 7, which is c to the 15. Okay, then it gets a little more abstract. We could do, where'd that one go? A to the b times a to the c. Okay, well, I don't know how many a's to write out or how many a's to write out here, but I do know that my rule, I would add them up. So a to the b plus c is your final answer. It's a little more advanced and crazy, but we can kind of see following the pattern that that's how it would go. So then for division, if we have w to the 10th divided by w to the 6th, again, we picture these are 10 w's, these are 6. We're crossing out the ones that are the same, and so on top we're going to be left with 10 minus 6 is 4 w's. And this one would be really crazy to write out, but this one, the trick for powers of 10 is the exponent tells you how many zeros. So this would be 4 zeros or 10,000. So either one of those would work. What if we had something crazy like p plus q, and this is r, and this is s. So here's the thing, notice that these rules work only when the bases are the same. So these bases are all the same, so it works. Well, here the base looks a lot more complicated, but it's still the same, so we're going to use the same pattern. We keep the base and we subtract the exponents, r minus s, and there's our answer. Now let's say the bases were different. Let's say we had, let's say we had 12 divided by 2 to the 3rd or something like that. We could technically rewrite 12 as a product of a power of, so this would be 3 times 4 over 2 to the 3rd. Well, 2 squared is 4, so this is 3 times 2 squared over 2 to the 3rd. So then we have 3 times 2 to the negative 1, or 3 times 1 over 2, which gets us 3 halves. If you see how that works. So sometimes your exponents are hidden, but you could still use these properties, although honestly it's probably easier to just simplify fractions, but it still works. Okay, what if I have something like 2p times 3p times 4p squared? Okay, here I'm just going to multiply my coefficients like I normally would, and I'm going to kind of show this just to make it clear. So I'm just kind of rewriting the problem first so you can see these pieces are all going to go together, and p times p squared is going to go together. So now I have 2 times 3 is 6, times 4 is 24, p to the 1, 2, 3, 4, p to the 4th. Okay, so the important thing to remember here is that in between the 2 and the p, and the 3 and the p, and the 4 and the p is multiplication. So this 4 is not being squared, only the p is being squared. So we can actually rewrite this just like 2 times 3 times 5 equals 3 times 5 times 2. We can do it in any order. Here we can scramble the order around so the numbers are all grouped together and the variables are all grouped together, and then simplify it from there just to make life a little easier. All right, let's do 18p to the 4th over 3p squared. Well, again, these are just being multiplied by this. They're not glued together. They're separate. It's all multiplication. So I'm going to divide the numbers. So 18 divided by 3 is 6. And then I'm going to divide the variables, and here when I divide the variables I subtract the exponent. So this is p to the 4 minus 2, which is 2. Okay, find another example. Let's see. Oh, here's a good one. If we have 1 over 2 to the negative 7. So this is tricky because before, when we talked about negative exponents, they were in the top and then we flipped it to the bottom. Well, here it's the same idea. It's the opposite. So if normally in an exponent is saying multiply, this is saying do the opposite. It's in the bottom. Opposite of division is multiplication. We're going to just flip it up to the top. So this is 2 to the 7th over 1, which is 2 to the 7th. I know that explanation was not very clear. It's been a long day. But hopefully you get the idea that if it's on the top, if we had 5 to the negative 2 over 1, we would move it down. So this would be 1 over 5 squared. If it's in the top, it moves to the bottom. If it's in the bottom, it's going to move up to the top. Okay. Let's do one that's just a little different. Okay, let's do this one. We have 2m squared n to the negative 4 divided by 5p to the 4th r to the negative 3. Well, here all of my bases are different, so I'm not going to be able to simplify by combining anything, but what I can do is take care of these negative exponents. So 2 2 stays, m squared, that's a positive exponent, so that's going to stay. 5 is going to stay. P to the 4th is going to stay. So these are all positive exponents. They're going to stay where they are. But this n to the negative 4, that's negative, so it's going to move to the bottom. And this r to negative 3 is negative exponent, so it's going to move to the top. And there we go. There's our answer. One thing I want to point out is people start doing this and then they start looking at something like negative 4x squared over 2y to the negative 3. People are going to start, you just start seeing a negative and wanting to flip it. So you're going to want to flip this negative 4 to the bottom. Nope, it only counts if it's an exponent. Remember, this negative 4 is just a negative 4. It's the exponents where they're telling us to multiply or divide. That's where we're flipping around. So this would be negative 4x squared. This stays, and then this is going to move up. So we've got y to the 3rd on top now. And then negative 4 divided by 2 is just negative 2x squared y to the 3rd is our final answer. Okay, here's a good one. If I have e to the 3rd times e to the 4th squared times e to the negative 2. The first thing I'm going to want to do is deal with this parentheses here. So e to the 3rd times e to the 4 times 2, right? This is 4 e's and 2 sets. So 4 e's and another 4 e's is a total of 8 e's times e to the negative 2. And now I could rewrite this e to the 3rd, e to the 8th over e squared, and picture that I'm writing these all out and crossing out. So I'm going to end up with e to the 11th over e squared, or e to the 9th when I subtract. Or from here we could just go e to the 3 plus 8 minus 2, which is also e to the 9. Either way is going to get you there. And that's one of the things I love about these exponent rules, is there's actually a lot of different ways to see it, and as long as you can get to the right solution, there's no right or wrong pathway. Let's see. Let's take it up another notch. Let's look at this one. So let's say we have w squared v times wv to the negative 2, all divided by v to the negative 3, w to the 5, vw squared. All right. So some people like to deal with the negatives first and flip everything around. Some people like to just rewrite everything together. So there's more than one way to do this. I think I'm going to deal with the parentheses first. So this is w squared v w to the negative 2 v to the negative 2 divided by v to the negative 3 w to the 5 v squared w squared. So remember, if it's in parentheses, it's this whole thing being squared. So then we have let's see. I think I'm going to simplify the top and simplify the bottom and then worry about this. So here I have w to the positive 2 and w to the negative 2. So w to the 2 plus negative 2 times v to the 1 plus negative 2 over v to the negative 3 plus 2 times w to the 5 plus 2, which is going to get me w to the 0, which we know is just 1, v to the negative 1 over v to the negative 1, w to the 7. Anything divided by its exact same self is just 1, so this ends up being 1 divided by w to the 7th power. All right. Oh gosh, that startled me. All right, we'll do one last problem. So let's do this one, 3 squared t squared divided by 3 to the 4th w squared times t divided by w to the 5th. Oh, you bad bunny! Sorry about that. As you can see, my rabbit is eating all the buttons off my remote. Bad bunny. All right. So we have 3 squared. When you're multiplying a fraction by a fraction, you just multiply the tops and multiply the bottoms. You can actually just kind of make it one giant fraction. So we have t squared, and then this, each of these is going to get a 5th power. So this is times t to the 5th, and this is w squared times w to the 5th. So we end up with 3 squared times t to the 7th over 3 to the 4th times w to the 7th. And then these 3's we can simplify one more time, and we get, I have 2 3's on top and 4 on the bottom, so I'm going to cross 2 of them out, and I'm left with 2 3's on the bottom. So t to the 7th and w to the 7th, and that's my final answer. All right, thanks guys.